Hi everybody, Chris here, once again from the basement with the third part of my sequencer trilogy. If you've been following this, you'll remember that step 1 was breadboarding the 10-step sequencer, step 2 was building the 10-step sequencer, and at the end of that second video I said I was going to build a 16-step one with the ability to run forward, backward, and alternating. And I've done it, and here it is. This guy right here. I call it the Red Devil. Note the beautiful red powder coat on this. I used some of our bike frame equipment to turn this from flat black into nice shiny red. So, as promised, this is a 16-step sequencer, and here are the control voltage knobs right here with indicator lights for each one. And as I said, this can run forwards, backwards, or alternating. So I've set the tuning up on these control voltages as a simple major scale so you can hear easily what it's doing. And if I hit, this also has the same audio sync input that the other one does, and we'll get to more of that later. I'm not going to bother demonstrating it because you saw it in the last video. We don't need to do that again. The free running aspect of it is actually more fun to play with. So anyway, if I hit auto run, you will hear a scale. Of course, rate is adjustable. And slow it way down, or speed it up. And of course, we can reset on any step down to 4. We can go up from there. And so on. I'm going to put it back on 16. I had to use 2 knobs, one for forward and alternating and a second one for backwards. And here's alternating, which is a real trip. I'll let it get back to 0. Now watch this. That was tricky to engineer that, let me tell you. It involves relays which switch the clock signal from up and down into the counter chip, but I got it to work. And of course, reset works on that. But unfortunately, because of the way it senses where to reverse the action, there's a 1-step offset when it goes from up 4 steps to alternate. It goes to 5. And after working on this for about 3 or 4 months, I finally just gave up and accepted it. So then you have this mode, or the big one, backwards. And of course we can go up to 16 steps on that one too. That was hard. It involves binary encoders, the way it has to load in the binary count into the counter chip, etc. was extremely complicated. If you want to know more about it, send me an email, post on Facebook, whatever. I'll tell you all about it, but I'm not going to get into this video because I'll just bore everybody. And of course, we can set that step down too. Now, part of the fun thing of this whole setup is having 2 sequencers to work with. And if you remember from our last video, I have these running into a Paya 9700 series modular synth with 2 oscillators, 2 tone sources. And so we can do things independently, or we can have them interact, which I think is so much fun. So if I take the original sequencer and connect its trigger, oh heck, I'll just go like this and let it free run, you won't hear a thing because I set it up wrong. Part of the danger of a modular system is that sometimes you can lose control of it, like I just did when I set that up and no sound came out. So I just paused and reset so that you can hear the sequence that this is putting out. This is also set to a major scale, right? Okay, now I'm going to set it up so the 2 of them interact, which I think is the best part of all. Because of the way this system works, we can actually have one sequencer affect the other one and actually transpose the sequence by a set number of steps if we want it to. Now, one thing that the 16-step sequencer has that this one doesn't is a step 1 output. Every time it resets to 0, or 1, in this case 0 in binary but 1 in decimal, it will send out a trigger pulse only on step 1 from this jack. That will then advance this sequencer one step, and I'm going to get rid of this patch cord because I know that's going to mess stuff up if I leave it. And when it runs through its sequence, it will then trip this, which will advance one and transpose it again, and so on. So hopefully I've got this set up right. Let's see, let's take this cord and plug it in here. I converted this. This used to be an audio input for audio sync. I transformed it, I rearranged it into a DC trigger so that it can read signals from here. So hopefully I got everything right. And if I turn the pitch down. Nope, not right, but I know how to fix it. There we go. And so on. And it really becomes pretty interesting if you put it on alternate and let it run through the 16 steps. It draws a little bit of current on step 1 for that reset, so I found that I actually have to tune it a little bit sharper. So one thing that you can have a lot of fun with is taking the number of steps here that reset and changing the number of steps here that reset. For example, if we take this and turn it down to 4, and take this and turn it down to, that should be 2, let's see. Well, that's 1. There. Okay, now it'll just alternate between 2 patterns. If we turn that down. That's a nice background, kind of nice swirling background. But we can take this and turn it up. That's not tuned exactly right, but you get the idea. And any number. Alternating, backwards, forwards, whatever. And so on. The possibilities are endless. And you can have all sorts of weird random fun too, as you're about to see. Okay, so here's another little bit of weird fun you can have because there are 2 oscillators and 2 sequencers. Because this has trigger output and this has trigger input, we can sync the 2 together and have them run it in opposite directions and run the 2 oscillators separately. And if I turn this one on and turn the balance over, you'll hear this is what this sequencer is putting out on oscillator 1. But you see that this sequencer is running in exact time and it's putting out these notes. The pitch is going up. So what happens when you put it together? All sorts of weirdness. And of course you can reset any number of steps there too. And just have all sorts of random craziness. And boy, what a light show! I mean, isn't that the point of this modular stuff anyway, analog sequencers? Come on folks, really. It's LEDs, it's blinking LEDs, that's the best part. And you put it on 16 steps, and it just doesn't get any better than that. There, 10 here, 16 there. Going in opposite directions. Couldn't be any better. Speed it up. Hypnotic. So anyway, what's next after this? Well, I'll tell you. I need a clock divider. which will be a device for simply taking pulses out of here and dividing them by X number of, well, just X, so that for every 2 pulses here, it puts out 1 here, or 1 here, 3 to 1, or 4 to 1, or 5 to 1, so that you have different ratios instead of it being locked together and just having step number 1. That's one thing. The other thing is a pulse stretcher or shortener for the gate input, so that you can have notes connected or detached, that is to say staccato or legato. That would be a nice thing for live performance. But for now, I'm happy, and I know what some of you on Facebook are going to say, my old high school friends. Great, Chris, now let's hear some music with it. Well, I'm up to the challenge, and I'm going to do it. So the next thing I post hopefully will be a song of some sort done with this equipment, just to satisfy everybody that thinks it's not possible. So from Chris's basement, I say once again, thanks for watching. Over and out.